welcome to OFHS Monday Night Football. What's that? We're not allowed to play sports right now? Welcome back, everybody, to Monday Night Factoring, where we have a battle between the Olmsted Falls Bulldogs versus Mr. Zrunner's Math Problems. What's up, everybody, and welcome to Special Factoring. We've done some basic factoring. We've used the algebra tiles and so forth, and today we're going to look at some special factoring. So I've got 9 problems that kind of stand out here as a little bit different. So follow along, or if you see one that you definitely need help to, feel free to jump in the video right to that problem. I'm going to go ahead and just get started off with what we know how to do already. We've been using the generic rectangle. This just gives us a visual of what factoring means. Remember, to factor a number like 10, you need like 1 times 10 or 2 times 5. So when we are dealing with a quadratic like these over here, we basically need to turn all these numbers and all these terms and these variables into a rectangle, a generic rectangle, that becomes base times height. If we can get base times height, that's factoring. Just like 10 is 2 times 5 or 5 times 2, we're going to try to turn all these into a base times a height. So we've been working on putting the x squared, so that makes it a quadratic, in one corner. It doesn't matter which corner, but because that is made up of x's, that'll come into some x's here and some x's over here. The only thing that can possibly go in this other corner is the number that's just by itself with no variable, so that is the 3. The key to all of factoring, remember factoring means multiply, is to multiply this diagonal. So when I multiply this diagonal, 2 times 3 gives me 6, and the x squared. There I'm looking to factor 6, right? Only a couple ways to factor 6. Which of these combinations is going to give me 5x? Well, none of them really give me 5x, so I could put all these x's here if it helped, but today I'm going to shorten up that process so I don't have to write that every single time. But I got 2x squared. I need 5x. I think I can get 5x right here. And then I have my 3. So it doesn't matter where I put these. 2x there, 3x there. I haven't factored yet. Factoring is when I find out what is the base times the height. So what is a common factor in this row right here? You can see there's a 2 and an x. Or some kids might focus on the x squared and go, that's x times x. Now where does the 2 go? Does the 2 go into 3? Well, with a decimal, we don't want to do that. 2 goes into the 2, into this row here. So 2 times what gets you 2? That is just 1. 1 times what gives you 3? 1 times 3 gives you that, and then we can see 3x fills in the last part. So now we have our base and our height. We can go write our answer for number 1, and that would be 2x plus 3, everything's positive in this, times x plus 1. So there's our answer to the first one that's factored. So nothing too crazy on that first one that we had to worry about, just a little bit of a review. We're going to go ahead and take a look at number 2 here. I think this is the first one in our class that this thing will happen, this kind of weird thing will happen. We put our x squared in there. We know that x's are going to have to be in common here and here, so that means the -7 has to go over here. The key to factoring, multiply the diagonal. That gives us -7x squared. I'm really just focusing on the -7. So like 1 times -7 or -1 times 7. 2 doesn't go in, 3 doesn't go in, 4, 5, 6 don't go in. These are all my factors. Do you see 5x here? I don't see a way to get 5x even if I put the x's there. If these combined, that would give me 6x. If they combined, right? Because I'm going to combine 2 spots. These combined, that gives me -6x's. So there's not a way to get 5x's. The answer to this problem is can't factor. And that's our first problem I think we've dealt with in class. That is a can't factor problem. So we still didn't know that right at the beginning. We got to set up the boxes and see what happens in that. We're going to take a look at number 3, and something might look a little bit different to you in number 3. We can go ahead and still set it up the same way. Our 3x squared we can put in the corner. We can take our constant number, that -14, we can put that in a corner. And we multiply the diagonal, the same thing we've been doing, right? I think that gives me -42. And I'll put the x squared there just to remind me. Ways to factor 42. 3 times 14 just went in it, so I know I need that. 4, 5, 6 times 7. And then I definitely need a negative here. I'm not sure where yet. It looks like my x's need to be positive. So if I'm thinking about where I might want to put the negative side, I might want to put the negative on the less. So I have more positive x's. I need a positive x, so I would maybe want to put my negatives there. And the part that makes this a little bit different, or special factoring for today, this x right here really means that we got 1x. So which combination gives you 1x? That would be 7x minus 6x would give you 1x. You can put those wherever you want. 7x minus 6x gives us that 1x in that problem. Now we're going to go ahead and factor. I like to start with the x squareds and do x times x. Does 3 go into negative 6? Yes, it does. Does 3 go into 7? Nope. 3 goes into the 6. How many times does 3 go into negative 6? Negative 2. How many times does negative 2 go into negative 14? That would be 7. 7 times x gives me 7x. 7 times negative 2 gives me negative 14. I've got my factors. I'm ready to go ahead and write my answer. My answer is x minus 2 for one of the factors, and 3x plus 7 for the other factor. So we've got our first couple problems out of the way there. Not too shabby, nothing too crazy, but a little special, a little bit different. Take a look at number 4, and you might notice that it seems like something's missing in that problem. If you want on number 4, you can rewrite it as 9x squared plus 0x minus 4. There are 0 x's. There's nothing in the middle there. That might help give you a better visual of what are you trying to do when you go set up your box method, when you go set up your generic rectangle. You put your 9x squared in a corner. On the other diagonal, you got your negative 4. You multiply the diagonal. That gives you 36 with a negative x squared. And I could go ahead and list all the factors of 36 or negative 36, but I need to end up with 0 x's. What is the only way to get 0 x's? 5 x's and negative 5 x's, or 4 x's and negative 4 x's, or 86 x's and negative 86 x's. They got to cancel out, because remember, they didn't even show up in the original problem. I get this as a common answer. 18 times 18 is not 36. We need to be thinking about what number multiplies the same number. That would be 6 times 6. If we use that negative, and if it helps to put those x's in there, 6 x's minus 6 x's, it's going to be 0 x's. It's not even going to show up in the problem. So 6 times 6 gives me the 36 I'm looking for. I need that negative to cancel out. So I'm going to go ahead and put 6x. I'm going to put negative 6x. I can start with the x squareds if I want, or you can start with the negative row if you want, if that's easier for you, right? I always like to start with the negatives if I have those in a whole row. So I can see a negative goes into that row, and then 2 goes into both of those numbers. 2 times 3 gets me there. Oh, that tells me I need a 3 up there. Negative 2 times 2 would get me to 4, so I need a 2 up there. Let's check and see if I'm missing anything. I got 9x squared, and you got 3x. I need to multiply by another 3x. 3 times negative 2 works. 2 times 3, and 2 times negative 2. I got my factors. I'm ready to write my answer. I got 3x plus 2, and I got 3x minus 2. This problem, we can go ahead and add a vocab word here. This is called a difference of squares. Let's think about what those words mean for difference of squares. And maybe you hear my dog River barking in the background. That's because my fiance Hannah just got home, so River's going to say hi. A difference of squares, if we look at the original problem, a difference means what's the difference between our ages? What's the difference between you're at the amusement park and they guess your age or your weight, right? The difference you would subtract. Look at the original problem had a subtraction in it. This could be a difference of squares problem. Squares is plural, but if we think about square as a number, 9 is a square number. It's 3 times 3. 4 is a square number. It's 2 times 2. You remember how we factored and we got negative 36 right here? That's a square number, 6 times 6. So we're working with squares through that whole problem. So if you have squares in the first part and squares in the second part, you might have a difference of squares. If you have that difference, you have that subtraction problem there. So we got a difference of squares for number 4. That's one of our new vocab. Take a look at the next problem. Do you notice anything? It's subtraction, which means it's a difference. And then 25 is a square number, 5 times 5. And negative 4, or 4 is a square number, 2 times 2. We're going to end up with a similar thing as to what happened on the last one. We take a look at number 5 over here. And we go ahead and set up our boxes. We got 25 x squared in the corner. We got negative 4 in the corner. We multiply those, that's negative 100. Put the x squared there if it helps you. What's a way that you can take 100 as a square number? That's 10 times 10. Don't forget the negative. So I got 10 times negative 10. If you notice, 10x minus 10x is going to give you 0x, which is that middle. So whenever we have this difference of squares, we're going to be ended up with the same number. A square number is 5 times 5, 2 times 2, 10 times 10. So we can fill those in. If you want a little hint every time a difference of squares problems happens, like when you're focusing on your x squareds here, it's not going to be 1 times 25. It's a difference of squares. You got to break it up into the squares. That would be 5 times 5. The only time you can do this little shortcut, this special little trick, is if it's a difference of squares. If it's a difference, two numbers, there's 0 x's in the middle, and there is squares on both of those pieces. What gets you to 5 times what to negative 10? That's negative 2. Negative 2 times 2 will get me there. You notice in the difference of squares, it's going to be like a square, the same on both sides. 5x and 5x, a 2 and a 2. The only difference is just that negative on one of those sides. Look at the problem right before it when we did the difference of squares. Everything was the same in each of these, except for one had a negative. Same thing here, 5x plus 2. 5x minus 2, same thing. Only happened, the only difference was the negative there. Do you see any other difference of squares in these? Ooh, I got a difference. Ooh, 16 is a square. Is 12 a square number? Nope, it's not a difference of squares. Here's a difference. 10 isn't a square number, right? 5 and 5, that's adding, right? Square number would be like 5 times 5 or 3 times 3. Ooh, here's that 4 is a square number, 2 times 2. 25 is a square number, 5 times 5. Is it a difference problem? Oh, it's not. It's not a subtraction problem. We don't get to use that trick. 40, is that a square number? No, 49 is, but 40 is not. So these are the only difference of squares ones on this whole list, but that's our new vocab for this section. So hopefully that's not too crazy for our special factoring. We still use the same strategy we've done the whole time. Number 6, a little bit different. In number 6, we go ahead and set up our boxes. We set up our 12x squared. We go put our real number and we realize where is the number that's all by itself with no variable. If you want, you could add a plus 0 on the end. 0 is the number. Pause there, soak that in, think about it. Are you okay with it? If not, send me an email, ask me a question, right? We got our x squareds, and then the number goes over here. Remember, the x has got to go over here. There is no whole number just on its own. There's no number without an x, so we're going to put a 0. We multiply the diagonal, we get 0x squared. 12 times 0 is 0. We're trying to factor 0x squared. What are some ways to factor 0? 0 times 1. 0 times 2, 0 times 3. See what's happening? I can keep going. 0 times negative 1, 0 times negative 2, 0 times negative. Wow, Mr. Z, do I have to list all of the factors of that? No, but we do need to find a way to get negative 16x. Well, it seems that we have to have a 0. Use that math. I got my math pants on, right? Use your math skills, see what's going on when you factor 0. We have to have a 0. How do I get negative 16x's? I put negative 16. So it would be 0x's and negative 16x's. Put 0x's and negative 16x's. Okay. 0 seems to be in common of that column. What seems to be in common here? A 2 would work, but think about greatest. What's the greatest thing that could simplify this? What's the greatest common factor that goes into this? 2 goes in, ooh, 4 goes in though, right? 4 would be the greatest common factor. Just kidding, I lied. 4 is the greatest common number that comes out, but a greatest common factor can also be a variable. Do we see that an x is also in common? We want to take that x out. Now we have the greatest common factor. 4 times what gets me to 12? And then we have 1x, we need another x to get that x squared, so there we go. 4 times what gets me to negative 16? That would be negative 4. Do I need another x here? Nope, I already got the x up top. So, when I go to factor this one's 4x plus 0, which I can just write 4x. Right? I didn't have to write plus 0 at the end of this problem. You could write 4x plus 0 if you want, right? That's what's written up here. Go for it. And then we got 3x minus 4. And we have now factored this. So we had to use that greatest common factor and a little special something that happened with the zeros there. So this is the first time we've had to factor 0. 0 times 1, 0 times 2, 0 times 3, 0 times negative 1, 0 times negative 2, 0 times what's the amount of x's that we needed? Negative 16x. Take a look at number 7. Something a little bit different about number 7. Remember, this is a special factoring for the day, so it's okay if something looks a little bit different. Again, if you got a question, email me, right? Send me a little message. I'll help you out. Number 7. It's just out of order. That's it. We got to do what we know how to do with factoring, which is take those x squareds and put them in the corner. Take that regular number, 3, and put it on that diagonal and multiply that diagonal. That's the trick. That's the key to factoring. 24x squared is what I really need to factor. Lots of ways to factor 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Do I see a way that gets me negative 10? No. See a way that gives me 10? How do I get negative 10 out of that? Do I have a negative to use? It doesn't seem that I have a negative to use to get to 24, but what if I did negative times negative? Does that still give me positive 24? Yes, it does. Negative and negative. Okay, now that gets me back to positive. Negative and negative, negative and negative. Do we see negative 10x's? I see them right here at the bottom. Negative 4x's and negative 6x's will give me negative 10x's. So I'm going to put negative 4x's. I'm going to put negative 6x's. X squared is made up of x times x. Does 8 go into 4? No. 4 goes into 8, but 8 doesn't go into 4. 8 doesn't go into 4. Does 8 go into negative 6? It does not. So we're going to have to factor this 8. We've got to break this down. What goes into both 8 and 6? Right? 2 goes into it. How many times does 2 go into 8? 4. How many times does 2 go into negative 6? Negative 3. How many times does 4 go into negative 4? Negative 1. How many times does negative 3 go into 3? We already have the negative 1. So we're still able to factor this problem, right? Just because 8 didn't fit in a row or a column, you can break it up. That's what we've been doing. We've been breaking up these numbers when we've been factoring this whole time. So I go to write my answer. I don't need my factor chart. I just need 2x minus 1. And I need 4x minus 3. And now I factor that. Okay? So just because it's out of order, don't let that confuse you. Just do what we've been doing the whole chapter. Put those x squareds down first, then deal with the whole number, the number that's on its own. The number without the variable. I keep saying whole number, but like 7's a whole number. I'm just talking about the number that does not have a variable, sometimes called a constant. Take a look at number 8. We have another missing some x's, so we need 0 at some point. So let's go ahead and take a look at number 8. We set up our boxes. Everything is in order on this one. 4x squared, boom. 25, boom. 4 times 25 is 100. I could put the x squared there to help me out. How am I going to get 0x in the middle. Remember how we got 0x before? 7 times 7, 5 times 5, 2 times 2, but you need a negative. You need 5 times negative 5, 2 times negative 2 to cancel it out, 7 times negative 7 to cancel it out. That's going to work, right? 10x's minus 10x's gives me 0x's. What's the issue? There's a problem with that. What's the number we're trying to factor? 4 times 25 is 100. Do I get to use a negative? No. Can I do this? Sure. Does that give you 0x's now? No, that gives me negative 20x's. How do I get to 0x's? I have a positive number. Is 10x's and 10x's going to work for me? No, I need 0x's. Do I get to use a negative? No, there's not a negative in the problem. I do not get to use a negative. This problem, like number 2, is a can't factor. This is a can't factor. It almost looks like a difference of squares. It's a squares problem. It's not a difference of squares. There's no negative that I have in this problem that helps me cancel out those x's. I need 7x's minus 7x's. I don't have a negative to use, right? So I can set up the boxes. I can multiply it. I can get that 100. But there is not a way to get to 0x's when I only have positive, when I have a positive number. So think about it. Don't go too fast. Double check your answers, right? Double check your answers, right? Cool, we're on to our last one. Number 9. Ooh, dang it. Number 9 doesn't have any x squareds. What do you think we put in the top corner with the x squareds if we don't have any? How about 0x squareds? Put the x squareds up in the corner. If you got 0, just put 0x squared there. What's our constant number that doesn't have any variable, no x's? That is a positive 40. Can I multiply the diagonal? Absolutely. What is 0 times 40? 0. 0x squared. When I multiply that diagonal, 0 times 40 is 0. You remember how we factored 0 before? Remember, use those math pants, use that math skill, use some common sense, think about it. You gotta think, you gotta problem solve in life. How do you factor 0? It's not on our factor chart, right? We have a factor chart of 0 or 1 to 100. We don't have 0 on there. How do you factor 0? 0 times 0, 0 times 1, 0 times 2, 0 times negative 1, 0 times negative 2, 0 times, what are we looking for? We need a negative 100x. Let's do 0 times a negative 100. Is that still 0? 0 times anything is 0. So is that going to give me negative 100 x's? Yeah. If I put 0x, so there's no x's here, and negative 100 x's here. Let's see if we have the original problem. We've got 40 minus 100x, minus 100x. And then 0x and 0x squared, that's 0. So we have the original problem, and we have it in our base times our height. We can now go ahead and factor. Hopefully we see the 0 across there. Maybe you see your x squareds and you want to do x times x, right? Something like that. Or maybe you just want to focus on the numbers here. Like, in these numbers, what do you see as the greatest common factor? I know 2 goes into those. That doesn't help me, right? 4 goes into those. That helps me out a little bit better. They both have zeros in it. What if I try 10 or 20 or 30 or 40, right? Does 10 go into both? Yeah. Does 20 go into both? 20 goes into that, yeah. 20 goes into that, yeah. Does 30 go in? No. Does 40 go in? 40 goes into that, but not, 40 doesn't go into 100. Does 50 go in? Now we're past this. So I think 20 was the number, the greatest common factor. 20 goes into this. How many times does 20 go into 100? 5 times. Don't forget the negative, and don't forget the x. 20 times 5 is 100. You got your negative, you got your x. How many times does 20 go into 40? Boom, that's 2. How do I get from negative 5x up to 0x squared? Oh, I think we mentioned before, if we had a 0 there, if you want to get your x squareds, we need 0 x's. Do I have to put 0 here? No, right? Was there 0x squared in the original? No. Did I have to write this? No. Just help me kind of understand the problem a little bit better. So now that I've got my factor chart all used, I've got my base times my height. I got 0 x's, I don't have to write that. That just means that 20 is my greatest common factor. And then I got negative 5x plus 2. So, let's wrap up some vocab. This one right here had a greatest common factor. You might hear some teachers talk about that as GCF, greatest common factor. You notice this one right here had a greatest common factor. Anything you notice about those two problems that are greatest common factors? Yeah, you can think about it. Anything you notice? Right, like this only has one term in it and there's not something else after it. This only has one thing in it. It doesn't have any x's after it. This has the x's but doesn't have the number, right? So these greatest common factors was something that we could just pull out in that problem. We had 2 can't factors in that problem, and then we had 2 difference of squares. Can you identify the difference of squares ones? They are the ones where the parentheses are the same thing, but there's a negative. Oh, but they're the same. Oh, here's a difference of squares. Same parentheses, just this one's positive, that one's negative in the middle. Here's your other difference of squares. All right, again, look back at the original problem. Difference means subtract. Squares means like 3 times 3, 2 times 2, 2 times 2, 5 times 5. Those were our difference of squares. These are our greatest common factoring. These are our can't factors. And that, my friends, is special factoring. Thanks for joining.